All right, let's talk about circles. This is from chapter 12. We'll come back to chapter 11. We're going to go ahead and do chapter 12. Um, Section 1, circles. The first thing that we're going to talk about are tangent lines. Now, we use the word tangent a little bit differently. When you think tangent, I know you're thinking SOHCAHTOA. Some old hippie called another hippie tripping on acid. Tangent is opposite over adjacent. But the use of the word tangent is also used when talking about circles. A tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. So if you look at this picture right here, line AB is tangent to circle O because it intersects circle O at exactly one point, and B is called the point of tangency. So a tangent to a circle intersects a circle at exactly one point. Now here's something that is true of a tangent. If you draw this radius from the point of tangency, you'll notice that looks like it's a right angle. There's a reason it looks like it's a right angle, because it is, and that's what theorem 12.1 tells us. I'm not going to spend the time proving that, but that is a right angle. If a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So we're going to use that fact to solve some problems. If a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. For example, AD and AG are tangent to circle O. What is the value of X? So you'll notice that AD and AG are two sides of a quadrilateral, and since they are tangent to circle O, that means this is 90 degrees and this is 90 degrees. So when you add up 152 and the 90 plus 90, or the 180, you get 332. So these four angles, 1, 2, 3, 4, those four angles have to add up to 360. So how much do you have left? Angle X is 28. Jasmine is riding in an airplane at an altitude of about 6.5 miles above the earth. Now this is impossible to draw this to scale, so just bear with me here, but she's 6.5 miles above the earth, so this is 6.5. How far on the earth can she see if the earth's radius is about 4,000 miles? So the earth's radius, so this green segment that I drew right here is about 4,000. So that's 4,000, as well as this. That's the same length. So that's 4,000. Now we've drawn the line that is tangent. We want to see how far she can see if the Earth's radius. So she's looking this way to see how far that she can see. So that is a right angle. And since that is a right angle, we have a right triangle. And that's the value that we're looking for. So we would work this problem like this. 4,000 squared plus x squared equals the length of the black segment, and the green segment is 4,000 plus 6.5, 4,006.5 squared. Now, I don't have a calculator with me to finish that problem. Just a minute, let me get one. All right, so 4,000 squared, 16, you're going to have 1, 2, 3, 4, 5, 6 zeros plus x squared equals, let me see what this is, 4006. So it's a very large number. Minus. And so x squared equals 52042.25. So x is the square root of that. Which is 228.1 miles. Do some more examples. what do I do here? The first thing is, what is x? Well, all the radii have the same value, so x has to be 9, right? So now I'm going to do the Pythagorean theorem. 9 squared plus 12 squared equals 9 plus y squared. That would be 81 plus 144 equals, if you fool this, you get 81 plus 18y plus y squared. If I subtract 81 from both sides, that goes away, and I have y squared plus 18y minus 144 equals 0. And so I can probably factor this. What would this be? Minus plus the factors of 144, that if you subtract one from the other, you get 18. Let's see. (24 and 6). All right. Yeah. So y equals 6. Y equals negative 24. That's a negative length, which does not make any sense. So we throw that away, and your answer is y equals 6. On this problem, if RF is tangent, it's a right angle, so x squared plus 24 squared equals x plus 18 squared, and you'd solve for x. I'm not going to work that. We just did an example just like that one. Let's look at this one. The question here is MN tangent to circle O? I mean to circle P at N. Well, if it's tangent, that means this is a right angle, and if that's a right angle, that means that 5 squared plus 12 squared equals this length squared. And this is 5, so that would be 18 squared. So let's see if they do. 5 squared plus 12 squared equals 18 squared. This is 25 plus 144. When you add those together, you get 169. That's 324. So they do not equal, which means this is not a right angle, and so MN is not tangent to that circle. Here's another fact about tangents. If two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So in this circle, both of these, they come from B. AB and CB are both tangent, and since they share that common endpoint, these two segments are congruent. For example, this circle is inscribed in triangle LMN. Now, a circle inscribed in a triangle means that it is tangent to each side of the triangle. What is the perimeter of LMN? So since it's tangent to each side, and that means that LO and LR are tangent from the same point, which means that they're equivalent. So that means that's 8, because that's 8. If NO is 5, then NT has to be 5. T is supposed to be right there. And then if TM, or if RM is 14, then TM has to be 14. So to find the perimeter now, I just add up all the sides. So that's 13, and this is 22, and this is 19. So that's 22 plus 13 would be 35, plus 19 would be 54, would be the perimeter. Let's do one more of those problems. Let's find the perimeter. If all of these, if that circle is inscribed in the quadrilateral, let's find the perimeter. Now, if it's inscribed, that means all the sides are tangent, which means this length and this length are the same. And so that's 8, and that's 8. If this is 3, then this is 3, so forth. So that's 4, so this is 4. And so this is 15, and part of it is 8, so the rest of it's 7. And this is 7. So we have 15 and 11 and 7 and 11. So that gives me 11 was 22. 22 plus 15 is 37, plus 7 is 40. 4 is the perimeter. Oh, that's what tangent lines are.